Let's take a quick break to review what we've learned. And just a reminder, I encourage you to turn off the recording and answer as many of these as you can from memory, and then go back and check the answer. So the first one, why can't we analyze categorical predictors without dummy coding? And the answer is because the regression process assumes that all the predictors are continuous. And that means that the levels of that variable mean something, such as a 1 to 7 scale for some kind of measure of personality or measure of cognitive functioning, etc. So it's like a spectrum of an underlying construct. That's what regression assumes. And so when we have categorical or grouping variables, we can't assume that. So remember, we had the psychology department was coded as a 1, and another department 2, and another 3. Well, department 3 isn't any higher on any attribute than department 1. They're simply arbitrary numbers assigned for grouping purposes. And so we can't use that kind of predictor in regression. We have to dummy code and make those codes zeros and ones so that the regression process will work as it is supposed to. The coding scheme that is most commonly used, I think, right now in research is the dummy coding. And in particular, usually it's used with two categories, like a 0, 1. And sometimes it's used with 3 or more categories. That's why it's important to know it. That's why we went over that. So I think it was last time. So it's important to know how to do dummy coding and that it is most commonly used. I would say it's used more than contrast coding. However, contrast coding is important when you have many groups. So maybe you have 5 departments or 6 organizations, and you have a special theory a priori about which ones will differ significantly from others. And so that's when you would use a contrast coding scheme. It has more statistical power because for dummy coding, for 6 levels, you would need to create 5 dummy codes. But a contrast code, if you want to contrast organizations 1 and 2 against organizations 3 through 6, for example, you would just use one numerator DF rather than the 5 that you would use in dummy coding. So it's really important to understand why and when you would use the contrast code versus the dummy code, and that the contrast code gives us the higher power. What does the constant represent in dummy coding? The constant represents the mean of the reference group, whichever group you designate as that. It will be the mean of that group. And the B weights represent the focal group's mean minus the reference group's mean. And of course, if those are significant, then we know that that's a significant difference. What do the B weights represent in contrast coding? In contrast coding, the B weights represent the difference between the groups that you coded negatively versus the groups you coded with a positive sign. So if those are significantly different, you know that the contrast that you created, contrasting 2 groups of departments or 1 department against 2 other departments, or however you set it up, you know that the means are significantly different. So let's say, next one, write out an equation for the predicted value of the dv for a quadratic function. So remember, that is the predicted value of the dv is equal to the constant, or b naught, plus the b weight for the linear term. So we have the b weight, and then multiply that by your x term, and then add a second b weight for the quadratic term and multiply that by x squared. And of course, if you have a cubic function, you would add the b weight for that term times x cubed. But it just says quadratic here, so quadratic just means you go up to the squared and then stop. Write out the regression equation for predicted value of y for an interaction, and that's I just typed that out for you in the notes at the bottom of the slide. The predicted value of y is equal to the constant plus the b weight for x times the observed value of x plus the b weight for z times the observed value of z, and then a third b weight for the interaction term then multiply that by the product of x and z, or the predictor and the moderator. What are some synonyms for the concept of moderation? Remember, we have interaction, we have a conditional effect, and we have a multiplicative effect. So those are all the different ways to think about the concept of moderation.